objective today is angle pair relationships. Definitions. An acute angle is an angle with a measurement less than 90 degrees. So our example, we have an angle. This angle measurement is 60. So since it's less than 90 degrees, this would be considered an acute angle. Obtuse angles are angles with a measurement greater than 90 degrees. So our example, this angle measurement's 120. It's greater than 90, so it's considered an obtuse angle. And a right angle is an angle with a measurement of exactly 90 degrees. And so it makes an L. And this little box is a symbol to represent a right angle, which are 90 degrees. Complementary angles is a pair of angles whose sum is 90. So when we take two angles measurements, add them together, we should get 90 degrees. And so our example here, I have this angle that's 45 and this one that's 45. When I add them together, I get 90 degrees. So they are complementary. Supplementary angles is a pair of angles whose sum is 180. So we have two angles, one's 120 and one's 60. When I add them together, I get 180 degrees. And if you notice, when they're right beside each other, they're making a straight line. And a straight line's measurement is 180 degrees. Adjacent angles is angles that share a side, whether it's a leg or a ray, and a common vertex, which is a corner point. So if you look at our example here, this angle and this angle share this corner point, this vertex, and they share this ray. So this angle requires this point and this line, and this angle requires that point and that same line. Vertical angles are angles opposite each other when two lines cross, and these angles are said to be congruent, which means they have the same measurement. So when we look here, we have two lines that cross. A and B are opposite of each other where the two lines cross, so A and B are considered to be vertical angles. And linear pair angles, well, we know linear deals with being a straight line. So we have two angles that are adjacent and supplementary. And so if they're adjacent and supplementary, those two angles make a straight line. So here we have angle A and angle B. And if you notice, angle A and angle B share this point and this ray, so they are adjacent and supplementary, because you add them together, you're going to get 180 degrees, which makes this straight line. So linear pair is when two angles are making a straight line. So let's look at some examples when we have complex figures, not just one angle showing that already has the measurement. So if you see here, we have a complex figure. And if you notice, we have two lines that cross each other. So we know that if we have two lines, the angles opposite of where they cross should be congruent. And that's because they are vertical angles. Because the definition of vertical angles are two angles opposite of each other when they cross, when two lines cross. So these are A and B would be vertical angles. If you look at number 2, we have A and B, and what you should notice is this angle A and angle B both share this point or this vertex, and they also share this ray. So when they share a vertex and a ray, that is the definition of adjacent angles. We look at number 3. We should notice, okay, we have a straight line. These two angles making a straight line, so we know that they are supplementary. And we also should notice that angle A, which is right here, has this point and this line. And angle B uses that same point and that same line. So angle A and B are supplementary and adjacent, so they make what we call a linear pair. And number 4, we have lines crossing every which way. Well, we know that they're crossing each other, and we look at A and B. Well, A and B are opposite angles. They're opposite of each other when two lines cross. So that is the definition of a vertical angle. Because they're opposite of each other when two lines cross. So now we're going to take our understanding of all of that vocabulary and find a missing angle based on the information we have given. So if you look at number 1, they gave us an angle that's 50 degrees and they gave us angle B. You first need to figure out what type of angles these are. And so we notice that these are adjacent because they share this point and this line. And they make a straight line, so that's a linear pair. So they're adjacent and they're supplementary. Well, we know supplementary means that the two angles should add up to give us 180. So we should have B plus 50 should give me 180. Well, now you just set up a one-step equation. So now we solve for B. Well, it's plus 50, so we subtract 50 on both sides, and we get B's measurement is 130 degrees. Well, 130 plus 50 does give me 180, and we know that that's the two correct answers because these are supplementary angles, and all supplementary angles add up to give me 180 degrees. So let's look at number 2. We've got an angle that's 90 degrees, and we have angle B, and we have all of these lines crossing each other. Well, we should notice that this angle of 90 and this angle of B are opposite of each other when two lines cross. Well, opposite angles when two lines cross are vertical angles. And the definition with vertical angles is all vertical angles are congruent. So if this angle is 90, then B should also be 90 degrees because they are vertical angles. And vertical angles are congruent. And this is your sign for congruent. Now, if we look at 3, they gave us, we have a 40-degree angle, a degree that's 6x plus 6x plus 2, excuse me. And then this symbol right here. Well, this symbol tells us that that angle is 90 degrees. Well, if that angle is 90 degrees, then this angle also is 90 degrees. So we have complementary angles. Well, complementary angles is two pairs of angles that add to give us 90 degrees. So I have 6x plus 2 plus 40 should give me 90 degrees. Now you can just solve this equation like you've been solving all year long. So we have 40, we combine like terms, 2x plus 40. So now I have 6x plus 42 equals 90. I want to find x. So I subtract 42 on both sides. I get 6x equals 48. Divide by 6, I get x to be 8. So if the question told you just solve for x, you would be done. If it wants to know the actual angle measurements, then what you need to do is plug in that x value back in. So we would have 6 times 8 plus 2. Well, 6 times 8 gives me 48 plus 2 gives me 50. So my two angles would be 50 degrees and 40 degrees. And 50 degrees plus 40 degrees does give me 90. And that's what we're looking for. So let's look at number 4. And number 4 is a little bit different. We are given adjacent angles. And then we're given the measurement of the outside. So everything that's not included inside this V. And that's 296. Well, an entire circle, so this part that was not included, an entire circle is 360 degrees. So you first need to find out how much is not on the outside. So we have 360 degrees minus 296. And we get 64 degrees. So from this ray to this ray is 64 degrees. So now we should know that this was cut in half. So these are adjacent angles. If we add these two angles together, we should get the entire angle of 64. So we have x minus 24, that's that first angle, plus the second angle of 29 should equal the 64 degrees that was left over. So now you need to combine like terms. So we have x, negative 24 plus 29 is 5, which equals 64. My goal is to solve for x. It's positive 5, so I subtract 5 on both sides. And so I should get x to be 59. So x is 59. And then if we wanted to solve for what this actual angle measurement is, we would plug 59 in for x and solve.